Hello, this is Mrs. Decker, and this lesson is on Objective 1C, converting the number of particles, mass, and volume between two different substances involved in a chemical reaction. This video will focus on just two-step problems. Before we get started with today's lesson, I want to do a quick warm-up of what we learned yesterday. So go ahead and pause this video and do this warm-up problem. Alright, so the question asks how many moles of oxygen are required to fully react with 8 moles of lead in this reaction. So 8 moles of lead is our given information, and moles of oxygen is what we're looking for. So start with your given information and draw your T-chart. And now remember, we want to use the mole ratio to convert between moles of lead and moles of oxygen. So we have 2 moles of lead for every 1 mole of oxygen. So put 2 moles of lead on the bottom and 1 mole of oxygen on the top, because you want your units to cancel diagonally. So moles of lead will cancel and we'll be left with moles of oxygen, which is what we want. And we get 4 moles of oxygen. Okay, so our first example for a two-step problem says 1.5 moles of KClO3 decomposes. How many grams of O2 will be produced? So we want to use Mole Island to help us. You need to first figure out where you're starting. So if we have 1.5 moles of KClO3, that means we're starting at moles of our known substance. And the question is asking us for how many grams of O2. So that is going to be mass of our unknown compound. So we need to first start by going from moles of KClO3 to moles of O2. That's going to be step 1. And then from moles of O2 to grams of O2. And that's step 2. So go ahead and write your given information. And in step 1, we're going from moles of KClO3 to moles of O2. So in the equation, we have 2 moles of KClO3 to 3 moles of O2. So that gets us to moles of our unknown substance, and now we want to go to grams of our unknown substance. So we do that by using the molar mass. So we put 1 mole of O2 on the bottom, and the molar mass of O2 on the top, which is 31.98 grams. So if you look at the problem, moles of KClO3 cancels out, and then moles of O2 cancels out, and we're left with grams of O2, which is what we want. So you'll do 1.50 times 3 times 31.98 divided by 2, and that will give you 72.0 grams of O2. Remember, your answer needs to include 3 sig figs and units and the compound. Now, example number 2 says how many grams of H2O are produced when 2.5 moles of oxygen react with hydrogen. So our given information is 2.5 moles of oxygen. So we know moles of oxygen for our known. And the problem is asking us to find grams of H2O, which is mass of our unknown. So again, we're going from moles of our known to moles of unknown for step 1, and then moles of the unknown to mass of the unknown for step 2. So write down your given information. And we want to use the mole ratio to go from moles of oxygen to moles of H2O. So we have 1 mole of O2 to 2 moles of H2O. So moles of O2 cancel out, and now we want to go from moles of H2O to grams of H2O. So we do that by multiplying by the molar mass of H2O. So moles of H2O cancel out. We're left with grams of H2O, which is what we want. So we get 90.0 grams of H2O. Example number 3 says how many moles of NH3 are produced when 4.5 times 10 to the 24th molecules of nitrogen reacts with hydrogen gas. So our given information is molecules of our known substance, and we want to find moles of our unknown substance. So step 1 is to go from molecules to moles of our known substance, and then from moles of known to moles of unknown for our second. So write down your given information. And remember to go from molecules to moles of a substance. We use Avogadro's number, which is 6.02 times 10 to the 23rd molecules in 1 mole. So now we're at moles of our known substance. We want to go to moles of our unknown substance, which is NH3. So we're going to use the mole ratio from the equation. So we get 1 mole of N2 for every 2 moles of NH3. So you'll do 4.5 times 10 to the 24th times 2 divided by 6.02 times 10 to the 23rd. Now remember, it's important when you're plugging scientific notation in your calculator, especially when you're dividing by it, to put the whole number in parentheses in order for your calculator to calculate correctly. So when you do that, you should get 15.0 moles of NH3. All right, and our last example problem says how many molecules of aluminum chloride are produced when 8 moles of chlorine react with aluminum. So our starting information is moles of chlorine, and we want to go to molecules of aluminum chloride. So step 1 is to go from moles of chlorine to moles of aluminum chloride. Step 2 is to go from moles to molecules of aluminum chloride. So write your given information. And we want to use the mole ratio between chlorine and aluminum chloride. So we have 3 moles of chlorine to 2 moles of aluminum chloride. So moles of chlorine cancels out. And now we want to go from moles of aluminum chloride to molecules. So we want to put 1 mole of aluminum chloride on the bottom and 6.02 times 10 to the 23rd molecules of aluminum chloride on the top. So you'll do 8 times 2 times 6.02 times 10 to the 23rd divided by 3. And when you do that, you should get 3.21 times 10 to the 24th molecules of AlCl3. So now you've got practice problems in your packet. Go ahead and work on those and let me know if you need help.